Hi all, I am Shalu Rose, Assistant Professor in Triple Department from the Mrs.Shalu College of Engineering. Now I am explaining about single phase induction motor. A single phase induction motor comprises the single phase distributed winding on the stator and normal split gauge rotor. The availability of the wide variety of small size motors and fractional kilowatt ratings. Motors employs fans, refrigerators, mixers and vacuum cleaners, washing machines, other kitchen equipment, tools, fall family applications, etc. Beer of a single phase induction motor can be explained by the on the basis of the double field revolving theory and cross parameter field theory. The single phase induction motor is simple, robust, reliable, and cheaper for the small rating. They are available up to 1 kilowatt rating. It is the cross-sectional view of the single phase induction motor. There are five types of single phase induction motor. First one is phase induction motor, capacitor start induction motor, capacitor start, capacitor run induction motor, shaded pole induction motor, and permanent magnet slipped capacitor motor. Actually, it is the control features. The main part of the single phase induction motor is the stator and rotor. The stator is a stationary part of the induction motor. A single phase AC supply is given to the stator of the single phase induction motor. In this machine, stator having two winding, one is main winding, another one is auxiliary winding. Rotor is the rotating part of the induction motor. Rotor connects the mechanical load through the shaft. The rotor in the single phase induction motor is a full phase type rotor. And it is the construction wave of the single phase induction motor. You can start frame and inside the frame it is the stator and rotor and the motor shaft will be presented. Next one is the starting principle. The single phase induction motor consisting of single phase winding on the stator and the cage winding in the rotor. When a single phase supply is connected to the stator winding, a pulsating magnetic field is produced. In the pulsating field, the rotor does not rotate due to the inertia. Therefore, a single phase induction motor is not a self-starting and requires in some particular starting means. Two theories have been suggested for the performance of the single phase induction motor. First one is double revolving field theory, next one is cross field theory. Actually, some starting methods are provided in the single phase induction motor. They are split phase or resistance start, capacitor start, permanent split capacitor, capacitor start, capacitor run, electronic starter for the single phase motor. First one is split phase or resistance start. In this method, the majority employed in single industrial duty motors. These motors consist of the two sets of winding, namely start winding and or main run winding. The start winding is made from the smaller wire with which it offers high resistance to electrical flow compared to run winding. Due to this high resistance, the magnetic field is developed in starting winding by the current earlier than the run winding. The magnetic field of the development. Thus, two fields are 36 degrees apart, but this is small angle itself is enough to start the motor. Next one is the capacitor start motor. The winding of the capacitor start motor is almost like a split phase motor. The poles of the stator is set up by 90-degree apartment. To activate and deactivate the stator windings, the normally closed switch is used and capacitor is placed in series with the start winding. Due to this capacitor, current release voltage, this capacitor is used to start the motor and it will be disconnected from the circuit after applying the 75% of the rated speed of the motor. Next one is permanent split capacitor. In capacitor start method, the capacitor has no disconnect. It has to be disconnected after the motor reaches the specific speed of the motor. But in this time, the a run type capacitor placed in series the capacitor start winding or auxiliary winding. This capacitor is not continuously and it does not record any switch to disconnect in its the start use of the motor only. Thus, starting torque of the permanent split capacitor is like the split phase motor, but with a low starting current. Next one is the capacitor start capacitor motor. The features of the capacitor start and PSC methods can be combined with this method. Run capacitor is connected in series with the capacitor start winding or auxiliary winding, and start capacitor is connected with circuit using the normally closed switch while starting the motor. Start capacitor provides the starting boost to moves to motor and PSC provides the high running to the motor. It is more costly but its facilities high starting and breakdown torque along with smooth running process of the motor. Next one is the electronic starter. The electronic starter is used in the motor protection from the overload and the short circuit conditions. The current sensor is the circuit used in the limit the current drawn by the motor because of few cases such as failure of the bearing, pump defect or any other reason. The current drawn with the motor exceeds its normal rated current. In this condition, the current sensor trips the circuit for protecting the motor. Next, the comparison between a single phase motor and a three phase induction motor. In single phase induction motor or simple construction, labor and economical vary for a small power rating as compared to three phase induction motor. The electrical power factor of single phase induction motor is low as compared to a three phase induction motor. For the some same size, the single phase induction motor develop about 50% of the output as that of three phase induction motor. The starting torque is also have as asynchronous motor, single phase induction motor. The efficiency of the single phase induction motor is also less compared to the three phase induction motor. Thank you.